In this video, we are looking at the 7.3 slides and the problems there. We're starting on page 5, where we're asked a simple random sample of 22 IQ scores is obtained. Construction of a confidence interval for the population standard deviation sigma requires the left and right critical values of chi-square according to a confidence level of 95% and a sample size of n equals 22. Find chi-square L and chi-square R, the critical values of chi-square, separating an area of 0.025 in the left and right tails, respectively. To do this, we'll go to a chi-square table, which we will find over here. We are looking for values for chi-square L. We're going to look in this 0.975 column. For chi-square R, we'll look in this 0.025 column. It's telling us that 97.5% of the data is to the right here, and 2.5% of the data is to the right here. We know that there are 22 IQ scores in this data set, so we have 21 degrees of freedom. So we look at this row and we find that chi-square L is 10.283 and chi-square R over here is 35.479. For our next problem, we are asked, one second while I find that, go. We're asked to, a certain data set lists IQ scores for subjects in 3 different lead exposure groups. The 22 full IQ scores for the group with medium exposure to lead have a standard deviation of 14.29263. Consider the sample to be a simple random sample and construct a 95% confidence interval estimate of sigma, the standard deviation from which the sample was obtained. So, go back here and we can fill this in. This is our formula to find sigma, or a confidence interval for sigma. We use the square root of n-1 times s squared over chi-square r is less than sigma, is less than the square root of n-1 times s squared over chi-square L. So n-1, that's our degrees of freedom, that's 21, times s is 14.29263 quantity squared. All over chi-square r, which we know to be 35.479. And we're taking the square root of all of that. That's less than sigma, which is less than, here we've got 21 again, and s is once more 14.29263. And again, we square it, and we divide that by chi-square L, which is 10.283. There we go. So then we will go and plug this into Desmos to get our values. Go and let's see, we've got square root of 21 times 14.29263 squared divided by divided by 35.479 gives us 10.996. And I'm just checking how many decimal points they want us to use for this. We're going to use 4 decimal places here, I guess. I don't think we need to use that many, but we'll use it for the moment. So, and they'll tell you in the problem in how many decimal places they want you to use. So we've got 10.9960 is less than sigma is less than, we will replace that denominator with 10.283. Get 20.425, 4250. Here is what that looks like at the end. We've got one more example. We want to estimate the standard deviation of all IQ scores of people with exposure to lead. We want to be 99% confident that our estimate is within 5% of the true value of sigma. How large should that sample be? Assume that the population is normally distributed. Well, for this, we want to use this table on page 351 of the textbook. You can find that in your e-text as well. It's the same information. We want 99% confidence that the S is within 5% of the value of sigma, and it tells us the sample size n should be at least 1,336. That is it for this video. If you have questions, please get in touch.